Hello everyone, welcome to yet another amazing session at Data Science Summit. Today we have experts from VMware who are going to enlighten us about cloud and virtualization. We have with us Ms. Sai Sandhya Pasupuleti, a member of technical staff at VMware, and Ms. Neelam Batra, a staff engineer at VMware. Ms. Sai Sandhya Pasupuleti is a well-versed designer and developer of applications, a juggler of software having worked on multi-tier projects, some of which includes Python, Java, Maven, Apache Tomcat, SQL, and many more. Ms. Neelam Batra is an expert professional with an established history of developing and managing projects in the IT and services industry. She has a strong engineering background, also highly skilled in languages like C, C++, Java, and master of varied technologies, namely ClearCase, device driver, STLC, Shell, Perl scripting, and requirement analysis. Society for Data Science BIT MESA is honored to have both the speakers on board with us, enlightening us with their vast experiences. We extend a warm welcome to both of them. Over to you, Neelam and Sandhya.
Yeah, thanks, Suryansh, for the fabulous welcome and the intro. So before, as Suryan said, that we'll be covering the virtualization and cloud computing topics. So myself and Sandhya will be sharing the overview for both. And before we start off, so let's have a poll. So the link is posted in the chat. That's https://pollev.com, Neelambatra 681. I request everyone to go to that link so that we know that where you stand. So I'll activate the poll. Yeah, I didn't get any responses till now. So I request everyone to respond. And if anyone is not able to access the link, I request them to put that response in the chat box. No responses? Yeah, I'll share the response window also. Yeah, the responses have started coming in. So it's a mixed response where I see, yeah, the responses are increasing. I'm new to these. Okay, that's good. So it's a mixture of the audience. 40% says that I'm new to these. The 40% says I have basic understanding of these, and 20% says I have heard about these and yet to explore more. So let's start with exploring more. So I'll just share my screen, the PPT. Yeah. So this was a brief intro about me, and as already it has been introduced, so I'll skip this slide. This is Sandhya. This is the poll. Now, before we get into the virtualization, let's understand what was the need of virtualization. So for that, we need to understand how the traditional architecture works. So this is a traditional architecture where we see that, assume that one company wants to deploy a mail server, web server, and the legacy application server. So in case of the traditional architecture, what they have to do is they have to buy a physical hardware, they have to deploy the operating system on which the application will run, and then they have to deploy the application. So three applications and three servers. So one server will be dedicated to the mail, the other one will be the web, and the other one will be the legacy application. So in this case, if you see that one server may not be, the resources of one server may not be fully utilized. So mostly we see that one server uses only the 30% to 40% resources. So the rest of the capacity gets wasted. Right? The same is the case with the web server. And you see that company has to invest a lot in buying the server, for maintaining the servers, and also if they want to create a standby or the backup for these servers, then they have to buy one more host, deploy the operating system, and then deploy the application. You think so? How much the wastage of resources happens, and how the cost goes higher. So if and I wish that if there's a technology or there's a possibility of deploying the web server on the mail server itself, so that the resources can be utilized better, and if possible, the legacy application server the application can also be deployed on the mail server. So that way we increase the consumption or the utilization of the resources, and the cost also decreases. So if I am able to install the web server and legacy application server on the mail server itself, so that way I save two servers, and those servers can be used for other deploying other applications, right? Uh, so I wish the technology should have been there. So the virtualization came from this use case where there was the need to deploy multiple servers or multiple applications on one server, right? So now this is the virtualization. So as I explained, the virtualization technology solves this problem by enabling multiple operating systems and applications to run only on one physical server or host. Right. So in this case, we see that in traditional server architecture, we had a physical server or the host. On that, we have installed the operating system, and over that, we have installed the application. So one physical server, one application. Now, when the virtualization came into picture, that time we have physical server or physical host. Over that, there's an abstraction layer. We call it a virtualization layer or the abstraction layer, which isolates the underlying hardware from the operating system. The operating system of the applications or of the servers which will be installing. So in this case, virtualization layer isolates, and over the virtualization layer we can install multiple instances of the operating system. So this one, each and every instance becomes a virtual machine, or it's a separate machine because it's a virtual. That's why we call it a virtual machine. In this case, the virtual machine operating system, there is a flexibility of having multiple or different operating system for different virtual machines. So one virtual machine can have Linux, the other virtual machine can have Windows. Now, these virtual machines, when a user uses them, there's no difference for him whether he's using a virtual machine or whether he's using a physical server, because it behaves like a single standalone server. Right? So the resources are dedicated. When we deploy a virtual machine, that time we put that time we configure that how much hard disk or how much storage it needs, what is the RAM capacity it needs. So everything is configured, and it becomes a standalone physical server. So it's an isolated one. Everything is encapsulated. There is no security issues. So each and every virtual machine works independently. So this is called virtualization. Now we should understand that how this virtualization works, right? So as I told you in previous slide also, means there is a hardware below which provides you the CPU, memory, and the disk usage. Over that there is a host operating system, and over that we install an abstraction layer which is called the hypervisor, right? So this hypervisor, or this hypervisor abstracts the hardware from the software, right? So this provides, this hypervisor is responsible for providing all the hardware resources to the applications. And then on the hypervisor we install the multiple the guest OS, the virtual machine which we install, and the OS which it has, it is called the guest OS, right? So the data storage also and the operating system, everything is abstracted from the underlying hardware and software. Right now, we can have this hypervisor installed in two ways. So one can be the hypervisor can directly be installed on the physical hardware, and the hypervisor can be installed on the host operating system. So in this case, if you see that hypervisor is installed on the host operating system, so when the hypervisor is installed directly on the physical hardware, it is called a type 1 hypervisor. And when it is installed on the host operating system, it is called as a type 2 hypervisor. So what are the few pros and cons of type 1 and type 2? So if you see the type 1 hypervisor, when it is directly installed on the physical hardware, it controls the hardware resources directly, right? So the performance increases because it has a direct control over the hardware resources, and there's no operating system in between which manages the hardware, right? So if you want to deploy application in the production, this type 1 hypervisors are preferred because the performance has increased. And if you see the security wise also, because there is no operating system in between, so the vulnerabilities which are there in the operating system, it is isolated from there, right? So it is more secure as compared to the type 2, right? Now why we need type 2 then? Means, see, the type 2 has its own pros. So it is easily manageable. So if you see, because all the hardware related functions are being managed by the host operating system, right? So the hypervisor has to do less work, or the delegation or the work done by the hypervisor reduces, right? So it's easy to manage. So that's why we say that when we have to test something, or when we are doing some POC, or when the production, or we don't have a large network, then we go with the type 2 hypervisor. Right? So a few examples of type 1 hypervisor: Citrix Zen Server, that's a type 1; VMware ESXi, that's a type 1 hypervisor; and Microsoft also provides one, the type 1 hypervisor, that is called Hyper-V. Now, type 2 hypervisors, Oracle has VirtualBox, VMware has VMware Workstation and VMware Fusion, Microsoft has Virtual PC, and Oracle has VM Server as well. So these are different types of hypervisor. Depending upon your need, you can use that. And because it's isolated, I mean, how you want to use and where you want to use, depending upon that, you can select whether type 1 is useful for you or the type 2 is useful. Now, this we spoke about the virtualization and how the virtualization works. Now we see that what are the advantages of virtualization, right? So in previous slide also we saw that many applications can be installed on one server using the virtualization. So it increases the resource utilization, and resource efficiency also increases. Now, because the number of server reduces, right? So as I explained with the previous example, with the example of the web server, mail server, and the legacy application server, we saw that the server count decreases. So it decreases the cost also, maintainability also. And these resources, the VMs, if you see the virtual machines or VMs, these are nothing but a bundle of configuration files. So it's very easy to deploy. You imagine if you have to deploy a physical server, right? So you have to buy it, then you have to install the OS, and then you have to install the application. The VMs or virtual machines are, because it's very lightweight, so it takes less time to deploy, and it's the provisioning is very easy and fast also. Right now, if you think about the disaster recovery or the downtime, right? So if something goes wrong with the physical server, right, then you have to install a new physical server, and again do or you have to take the backup of the physical server which you will be installing on the new physical server. In this case, the virtual machine, the snapshots can be taken at particular intervals. It's you can schedule that you want to take the snapshot. So if something goes wrong, you can just deploy those snapshots and your virtual machine will be ready. So the downtime also reduces and the disaster recovery becomes easy. Right now, because we have and the count of the servers have decreased, so the power utilization or the energy utilization is also reduced. So this helps in reducing the carbon print also. And as we said that it's easy to migrate, so that's why it becomes very easy to deploy, or it's very lightweight, so it becomes very easy to migrate to cloud. So in we can say that it enables the cloud computing also. Because of virtualization, the cloud computing is also enabled. Right. So with this, now let's understand what are different types of virtualization. Now we know that what is virtualization, how virtualization works. Now, what are different types of virtualization? Now, as we discussed that virtualization is nothing but what we do is we create a virtual version of something, right? Or a software version of something. This something can be a server. This something can be a desktop, a storage network, or application. It can be anything. Right? So based on the thing which we are virtualization, it is called either server virtualization or the desktop virtualization or storage or network virtualization. Right? So we just saw that where we created a different virtual machines, right? We installed different or multiple instances of the operating system on one physical hardware. Right? So that was nothing but a server virtualization, because there we are creating multiple instances of a server on a same physical hardware. So it's not existing in real world, but yeah, it's a virtual instance. So that is nothing but a server virtualization, right? And VMware has a product for that vSphere or ESXi provides a server virtualization. Now, when we come to the desktop virtualization, so in desktop virtualization, we don't virtualize the operating system, but what we do is we virtualize the workstation's workload. Right, so whatever application or on desktop, whatever is running, that will be virtualized, and anyone can access the desktop remotely, right? And we're using a thin client. So that is the advantage of having the desktop virtualization. So VMware has a product called VDI, virtual desktop instances, for the desktop virtualization. Now we come to storage virtualization. So as the name suggests, in this what we virtualize is the storage. right? So in this case, what we do is we pool all the physical storage provided from multiple network storage devices into a single storage device. Then it can be managed from a central console, and because it's a pool now, you can assign the storage to different devices or the applications, right? So this becomes the storage virtualization. So for a storage virtualization, VMware has the vSAN, virtual storage area network. Right, so next we come to the network virtualization. So as the name suggests, it's a network related thing. So in this case, what we do is we combine all the available resources in a network and split the whole bandwidth. Means when we combine all the network resources, we get the combined bandwidth, right? So that available bandwidth is divided into channels now, right? Now each channel is separate and independent. So this independent channels can be assigned or reassigned to a particular server or device in real time. And so this network virtualization allows us to run the applications on a virtual network, and it gives the same feel as I said for the virtual machine also. You will not know whether it's running in the physical server or whether it is running on the virtual machine, right? So same thing is true for the virtual network. You will not know that whether it's a virtual network. It behaves seamlessly like physical network, and it gives the operational benefits because runtime also we can change it, right? So now next is the application virtualization. So application virtualization is a software technology which abstracts the application from the operating system now, right? So application is completely separated out of the operating system, and the application itself runs in an encapsulated form without depending upon the underneath operating system. So because it's now separated out from the operating system, you can run any application on any operating system. So you think you can run a Windows application on the Linux server also, Linux operating system, right? So this is a benefit of the application virtualization. So workspace one is one application virtualization technique which VMware provides. For network virtualization also, VMware has NSXT, so which virtualizes the networks. Yeah, feel free to ask any questions. Please put them in the chat box so that we can take the questions in middle or in the end. And as told in the beginning, there are goodies to win. So please feel free to ask the questions.
There is a
So
question in the chat bot. So, what is essentially the difference between virtual machine and remote console?
virtual machine and remote console. That's what you said, Sandhya?
Yeah.
Right. So virtual machine is separate. Remote console is a remote desktop where only the desktop is virtualized. In VM or virtual machine, the operating system or full server is virtualized. So that is the server virtualization technique. Whereas desktop virtualization is the desktop, whatever applications are there, you can access your desktop, right? In your PC or your laptop, you will be having a desktop. So those applications can be accessed remotely. So there's a desktop virtualization. Any other questions, Sandhya?
No, we are good.
Okay, yeah. So with this means we know now what are the basics of virtualization, how virtualization works, and what are the types of virtualization. Now I'll pass on to Sandhya, who will explain about the cloud and cloud computing, and she will tell us whether we really compute in the cloud or what we do. Yeah, Sandhya, please take over.
Thank you, Neelam. So, having known about virtualization and where does it stand, so let's now move on to what is a cloud. So, as we all know, that cloud refers to the servers that are accessed over the internet, and we can access softwares and databases that are running on the servers as well. So, the cloud servers can be located anywhere, and it can be located in the data centers, which can be spread across the world. So by using cloud computing, users and other companies also help us, manage our applications without knowing where they're actually hosted. So, for example, you lost your phone and you want your Instagram account to be to get back the data of your Instagram and your videos, photos, and conversation history. So, this is when you have this cloud in place. So, the cloud ensures that the user has access to the same files and applications from almost any device, because the computing storage takes place on the servers in any data center instead of the locally held user device. So this is how, all these providers like Gmail, Microsoft Office 365, and other storage virtualization companies like Dropbox and Google, provide us the cloud storage so that it feels like, yeah, you have your data stored somewhere. So this cloud, having said this, so we also feel that we can manage the physical servers themselves, and we can run the software applications on their own machines without we actually owning the hardware or something. So you just have to pay for whatever you use. So it's not that you'll have to buy the whole hardware and you have to manage it and all. So some of the applications which have these cloud in place are email, web conferencing, and customer relationship management, etc., which is called the CRMs. So the main crux of this is you'll have to you'll access everything which is stored somewhere else, and you don't know where it is. You need not worry about data privacy. How is it managed? You need not worry about is it available always. You need not worry about what happens to my data if the server goes down and all. So all this is given by the cloud providers themselves. So having told this, let's move on to what is cloud computing. So cloud computing is possible by the term technology called virtualization, which Neelam has just explained us. So virtualization allows for the creation and the simulation of digital virtual computers, which behaves as if there is a physical computer with its own hardware. The technical term for such a computer is called a virtual machine, which we'll be using all through our presentation. So when it is properly implemented, the virtual machines can have same host, and they can be sandboxed from another. And it is not mandatory that all the applications may be running on one virtual machine. And these may not be visible that everything is hosted on one physical machine, and you can even access, like many users can access these applications and all. So virtual machines are a more efficient usage of hardware hosting themselves. So by running many virtual machines at once, one server becomes many servers, and a data center can be whole hosted data centers altogether. So this helps many organizations save their costs and all. So thus cloud providers can offer us the use of their servers to far customers, and they can also use this at a very low cost. So even if the individual servers go down, the cloud providers in general always have a backup plan. So you feel that they are always available and always online. So the cloud vendors generally back up their services on multiple machines, which can be across different multiple regions as well. So the users which access the cloud services can either go and have a portal which is hosted on a web server, or an application which can be on a handheld device as well. So you can connect to the cloud over the internet. So it is through a set of interconnected networks, regardless of what the device you are actually using. So having said this, let's move on. So earlier we have seen our generations and all, we have heard that, okay, when you are learning about something, let's learn about birds, trees, hills and all. But now, we hear parents telling to their kids about what is cloud virtualization, cloud computing and all. So the jargon is there in their head since since they started learning alphabets. So although equally buzzword technologies like virtualization and cloud computing are interchangeable, virtualization is a technique that helps computing environments like virtual machines independent of the physical architecture and the physical infrastructure available. So how does this make cost effective? So because it is like on demand, when you need it, you use it. So it is not like you have to pay for something what you're not using. So instead of owning the physical infrastructure all by itself, like this servers and data centers, you can just access a compute resource from a cloud provider like Google, Amazon, VMware, or anything. So for example, Amazon has infrastructure in all the regions. So you can get the infrastructure which is very close to your proximity, so that you can reduce the latency. It's like you feel the faster access. So you don't feel like, okay, you are accessing something which is far away. So it's like it is masking the actual, the distance of where the actual infrastructure is hosted and all. So it becomes very easy and even, scalable, because you pay for what you use, and you consume what is needed. You don't need to, ask for what you don't need. So this is how it becomes more and more agile as well. So as complementary solutions, many organizations can begin with virtualization and virtualizing their servers as well. So this helps in moving towards cloud computing and hence achieving greater agility, and even, this helps in self-service also. So having said this, let's move on. So
Yeah, just to add here, Sandhya, means one more example can be the big billion days sale, right? So Amazon, all the this e-commerce sites, they provide the big billion sales. So that time also means what they do is, because the load increases, so they can deploy the virtual machines and they can expand their workload, right? So because that time the demand is more, and once the big billion day sale is over, they can again reduce. You imagine if in the traditional world, means they have to buy the servers and then they have to dispose of, it must have
yeah.
been very costly. So here also the cloud computing helps.
Yes, right. So yeah, so it helps in scalability also. So it helps in
Yes,
addressing
right,
the scalability. Yeah, well
right.
said. So, the slide shows the deployment model. So the most commonly used deployment models are we have these are all mostly used in across like daily terminologies, and also we have private cloud, public cloud, hybrid cloud, and a multi-cloud. So a private cloud is something like a server and a data structure which is wholly dedicated to a particular organization. So they don't want to share the data with others and all. So it's like only within the organization you want to have all the data secured and all. So for example, in any, like for example, BAT Mishra itself has a private cloud hosted. So only those organizations or the educational institutions which have access to that particular network and connect to and access the machines or get the data and all. And having said this, and private cloud is a service which can be run by an external vendor that may include servers in one or more data centers. So unlike a private cloud, public cloud can have multiple organizations which are involved. So using the virtual machines, individual servers may be shared by different companies. So it helps in multi-tenancy as well. So multiple tenants are renting a server space, and which is sitting inside the same server. So for example, Amazon. So it has multiple multiple services which can be exposed, and it has its own security models in place. So a combination of public and private cloud is called as a hybrid cloud, and even it includes on-premise legacy servers as well. So an organization may use private cloud for some services, and it might need some other public services for other services also, right? So it can have a combination of both private and public cloud services altogether. So for example, public cloud can be used as a backup for the private cloud so that it will, high availability can be achieved. So then moving on to the multi-cloud. So multi-cloud is a kind of cloud deployment which includes multiple public clouds, and an organization which is having the multi-cloud deployment rents the virtual servers and services for several external vendors. So it is like multiple deployments can be done on hybrid clouds or different public clouds, and you can be hosted on private and a combination of both. So yeah, then moving on to service models. So having talked about the public deployment models, service models, we have service models like infrastructure as a service, platform as a service, software as a service, and not just these three. These days we have everything as a service. You name it, we just expose it as a service. So it can be like anything as a service. So which includes network as a service, business as a service, function as a service, database as a service, container as a service, or identity as a service, strategy as a service, or anything. It's just anything. You can just name it and you can expose it as a service. So software as a service is like instead of users installing an application on a device, these SaaS applications are hosted on a cloud server and users can access them over the internet. So let's link this to an real-time example. So it is like you want to rent a house. So there is a landlord which is having a house. So it's like the tenant mostly goes and uses the house. So in the similar way, you'll just use the services which are hosted by someone else. So this includes like Salesforce or a Slack or Mailchimp, for example. Then moving on to platform as a service, it's like companies don't don't pay for the hosted services. Instead, they pay for those things which are needed for them to build their own applications. So it is like, for example, there is a platform as a service vendor and he has everything which is needed to build a application. So you go and ask only for example, you go and say, I want only development models, I want only operating systems. So you can only access those instead of, paying for everything which is hosted by the platform as a service provider. So it is like you are renting those tools which can be used to build a house instead of renting the whole house as together. So some of the platform as a service providers are Microsoft Azure and Heroku. Then moving on to infrastructure as a service. So in this, a company rents the servers and the storage which they need from a cloud provider. So it's like the cloud infrastructure they need to build is let out by the infrastructure as a service provider. So it's like a company leasing a plot wherein you can build whatever you want. You can build a house, you can build a mall, you can do anything. So it's like they're giving you the infrastructure so that you can build it up whatever you want. So, for example, it is like some of the infrastructure as a service providers are Google Compute Engine, OpenStack, and all. So recently, people are using this function as a service more often. So it is like serverless computing, which breaks the cloud applications into smaller components so that you can run only that specific thing whenever it is needed. So it's like renting a house is split into different rooms. So if you want to dine at a particular time, so you go and use the dining table and the dining area. If you want to watch a movie at a particular time, you just say that I want to rent this particular hall or something. So it's not like you have to pay for the whole full house. So on demand, it's like if you want to use that particular kitchen for, let's say, a specific time, you say that I want this in this particular slot. So it is reducing the cost and all. Yeah. So let's move on to some of so having said this, then we'll see how are these cloud models in the real world. So I'll give it off to Neelam to explain how is service models can be used in our day-to-day life.
Yeah, thanks, Sandhya. So now let's understand. She has already explained few service models, and now let's understand this more in more detail using a pizza as a service. Or you want to do a pizza party, right? Pizza, everyone loves. So this may be interesting. So with this example, we'll try to understand how the cloud service models works, or what are the different cloud service models are. So now you assume that you want to do everything by your own. So you want to manage everything. The kitchen is yours, oven is yours. You want your own fire to be there, and then you want to bring your own pizza base, then ingredients. And now without drinks, there is no pizza. So you want your drinks also. Now you want to chit chat because it's a party, right? So the friends should be there, the conversation will be there. So everything, if you're managing by your own, that becomes like a traditional on-premises or legacy applications or legacy data center, where everything was managed by a customer. So they were having their own data center, own servers, own compute engine, so on own application. They develop their own application. So everything done by their own. So this is a homemade pizza, right? So in this case, we have to, or or a developer has to manage everything. So it becomes too much to manage. Now, what is the second version of that, or what is the different approach for that? So now let's consider infrastructure as a service. So we have a community kitchen, someone is providing us a kitchen. So we got the kitchen, we got the oven. So those things are now outsourced, right? So now we need not have a kitchen space, we need not buy an oven. Now we want a fire or electricity. Now we need a pizza, drinks, friends, and once we start the party, then conversation. So it becomes the same as an infrastructure service, where the basic infrastructure which is required is provided by someone else, right? So this is the community kitchen, where it's a infrastructure provided by the community kitchen. Now the third approach can be that we have outsourced the kitchen, oven, and fire also, or fire or electricity also someone else provides. So it is the container as a service. So you bring your own things only, the pizza, drinks, friends, and conversation. These are the things which you have to bring. Other things are provided by service provider. So this is a container as a service. Now the similar way, it can be we can go with the platform as a service, where we have outsource the kitchen, or there's some provider which is providing us a kitchen. He has his own oven, the fire or electricity. The pizza also he only gives. Now we bring only the drinks, friends, and conversation. So basic platform, or which I need for the doing a party, is provided by the service provider. So this becomes a platform as a service. Now, as we know that simply, so slowly, everything is becoming as a service. Now we have outsourced, or there is a provider, which service provider, which gives us the drinks also. So kitchen is there, oven is there, fire is there, pizza, drinks, everything is provided by a restaurant. You go to a restaurant, order everything, just take your friends along with you and start the party, start the conversation. So this becomes a function as a service. So slowly means we are outsourcing everything, or there's a provider which provides us more and more functionality. Now, the last one, where the SaaS comes, or software as a service comes, where we have outsourced a party also. So we have event managers now, right? So they host the parties, or sometimes we ask them to, for the get together also. So you go there and just make the friends and just start the conversation. So everything is outsourced, or everything is, for everything there's a service provider, and we just go and converse. So we are only worried about the data, right? So this becomes software as a service. Now, if we want to map it to the different layers, then it becomes the kitchen becomes the hardware, the oven or becomes the virtualization. Fire is mapping to the operating system. Then pizza is nothing but runtime what we need. Then drinks we scale. So whatever was there, some add-ons to that. So pizza is there, some more add-ons, so scaling. Then functionality, we want friends, and the configuration or the data is the conversation. So with this, we know that there are multiple service models, or many service models, and there are many companies which provide the software as a service, few provides platform as a service. And now slowly, if we see, everything is moving to the software as a service, because it gives us the flexibility to concentrate only on the data part or the conversation configuration part, right? We need not worry about the underlying infrastructure. So everything we can outsource, right? Let them manage. Why we should manage? And it becomes a cost effective also, because as Sandhya said, you pay for whatever you are using, right? So you will not be wasting. Kitchen is huge, right? So you are using only the one oven there. So you paying for the things which you are using, not for the extra things. So that becomes a cost effective, and it becomes easy to manage also. Now, this we saw with the pizza as a service. Now same thing, you will map it to the day to day, means, or the in the real data center, what happens, and how it is mapped. So if you see the data center, the traditional on-premise data center, their compute, storage, networking, hypervisor, operating system, container, application network, the applications, function, data, everything is a developer responsibility. So you are managing everything. So traditional was like that everything is managed by one person. So there is too much to manage, right? So you can consider on the functionality per se. Now, next phase came when the service providers came with, or the cloud providers came with the infrastructure as a service option. So where they said, okay, we'll manage your compute, we'll manage your storage, networking, hypervisor, and operating system. The other things you can manage, right? So the basic infrastructure is provided by the service provider, and you manage the other things. So this became the infrastructure as a service. Now slowly, if you see the concentration, or the importance of the things is changing, right? So the infrastructure is provided, or managed by the service provider. So our headache is decreasing, right? So we should concentrate on the things which we want to concentrate. So that way. Now the third came the container as a service, where with compute, storage, networking, hypervisor, operating system, and container also is provided by the service provider. So they are only managing the container as well. So as a developer, we have to be worried about only the network, application, function, and the data. Now then came the platform as a service. So and slowly it is evolving. So now with the container, the network also, we said that the service provider said we will manage you, where you just deploy your application, check the functionality and the data, right? You should worry only about the application, function, and the data. So that becomes a platform as a service. Now next phase came where they said, okay, you don't worry about your application also, that also will give you should worry only about the functionality and the data. So that becomes the function as a service. Now the stage has come where everything is getting provided by service provider. So here we are worried only about the data. So they are providing the software as a service, where all the applications are deployed already in the cloud, and you can just use that Means if you imagine you want to manage your network, right? So the application is already there in the cloud. You give them the details of the network, that which network you want to manage and what is the data. You just manage those things. So don't worry about the servers, where will be the server, how I'll manage the storage, how I'll manage the networking, what operating system I should use. So you know, not worry about that. You should worry about the business thing, business case, right? So that way, slowly, if you see, everything is moving to software as a service, and it is good for both the service provider as well as for the developers, because our headaches are decreasing. We can concentrate only on our business use cases, not on the other things, right? So now let me go to the application. Now we saw that multiple models are there. So there are different companies concentrating on different models, so, and slowly moving to SaaS, or software as a service. Now let's see what are the cloud computing applications, right? So as we know that everywhere we are using the cloud computing now, or the backend can be a cloud, and we might not be knowing and unknowingly also we will be using the backend as a cloud. So it is used in the business applications, for example Google Apps for business. So with Google Apps for business offers us the text documents, spreadsheets, presentation, etc. on Google Docs, right? So where the business users can share them in and share them with each other. Right? And the second application can be the QuickBooks. QuickBooks are the online accounting solution for a business, right? So you do not have the accounting softwares in your laptops. You can use this QuickBooks for your accounting solutions. Then social applications, means nowadays everyone uses Facebook, Twitter. So Facebook, you can share your photos, you can share your status, you can manage anything. You have so many friends there. It's same way the Twitter also. Twitter, you can follow someone and share your messages there. So these are the social applications which in the backend uses the cloud server. Now the application is there in the data storage and backup, right? So you have a lot of data, so where to store? So now if you want to store it locally, you have to buy the servers. So instead of that, few companies are there which provides you the data storage and backup solutions. Right? Now, next is the management applications. So there are applications available for management tasks, such as if you want to track the time or organize your notes. For that also, you have some applications which are deployed on the cloud. Next can be the entertainment application. This is the online streaming, right? So you have the streaming service. So the music files are already stored on the online on the cloud, and you can just play them. Right? You need not have the physical the CDs or physical. Earlier we used to have the CDs and other things, right? So now you need not store that in the songs in the laptops. You can just use these online services and play the music. Now, few applications are art applications. So art applications are used for creating your business cards, postcards, or mini cards. So these applications are also deployed on the cloud. So whenever you need, you just use them and pay for the time for which you are using them. So that's all. Now comes the data science, right? So how the data science is getting benefit with the cloud computing. Now, if you see the data science is all about data. So it has a lots of data. Now, if some company wants to store the data, then they have to buy the servers, right? So now they need a space to keep those servers as well, and so the data should not be lost. So that's why they will be taking the backup of the data. Now they need the servers, and they need the place to store the servers, then they need to back up those servers, maintain those servers. So it has a lot of cost involved, right? And they will not be taking a low performing servers. They need high performing servers, right? Because you will be running some algorithms or some models which takes long time and which needs a high CPU utilization, and it needs a GPU maybe, right? So that way the use of servers or the requirement of the server increases. So here only, if you see the cloud computing comes in. Now instead of buying the servers, what they can do is they can just use the online services, or they can save their data on the online servers, and just with because they will be the online, the service providers only will be taking the backup of the data. They should not be worried about taking the backup of the data, because they will take care. They will have the backup and backup servers as well, so that data is not lost. And those servers where the data will be stored, or that will be that will have the GPU also, so that you can run your algorithms or your models there. Right. So this way means, if you see that data science also has got benefited with the cloud computing, and it is going on. So there are multiple companies which provide the data analytic platforms. One is Amazon Web Services, Google Cloud, Microsoft Azure, and many others. So with that, if you see that day by day, the applications of cloud computing is also increasing. Right. So with that, I'll pass on it to Sandhya for telling us the providers, what are main cloud computing providers. Sandhya, back to you.
Yeah, so as the slide shows, these are the top cloud providers, competing cloud providers right now in the market. So when coming to VMware, it is the best. I mean, it is the third best party which provides cloud services. So VMware is a comprehensive cloud management platform. It helps us to manage a hybrid environment, and we can run anything, like starting from the traditional approach to a container workloads. We have every other service which is needed by the customers. So the tools also allows us to maximize the profits of the organizations who are approaching us for business solutions. So we even have enterprise ready hybrid cloud management platforms. We also offer private and public clouds. So comprehensive reporting analytics for improving the capacity and forecasting and planning of the costs and all is also a good feature of VMware Cloud. So in addition to all this, we also provide flexible and agile services to all the third-party applications, and even we help them to customize applications and tools. So having said this, Azure is also one of a cloud platform which is launched by Microsoft. So this is a open source and flexible cloud platform which helps in development and data storage and even service management hosting solutions. And Amazon is also one of the big competitors. So it has cloud hosting, web hosting platforms, and it offers fast, flexible, reliable, and cost efficient solutions. So we also have IBM, Alibaba Cloud, Salesforce, and all. So let's move on to the next slide. So we'll talk about what are the challenges of cloud computing. As someone asked about the security and all, yes, security is a biggest challenge in cloud computing. So security and privacy issues can be overcome by employing some of the encryption and security hardwares, and maintaining VPNs, installing firewalls, and also that we make sure that the data is not hacked, or there is no intruding of other networks and all. So the cloud providers themselves have some of the applications which are running to have this infrastructure security, data security, and physical security as well. And coming to portability, so applications which are running on one cloud should be migrated to some other clouds easily. But one such problem is that there is a vendor lock, so that the implementing a language of their platform might be different from the languages which are used by the other Google, other cloud providers, right? So this is one of the major challenges of porting the applications from one cloud to the other. And interoperability is like one platform should be able to incorporate the services of the other platforms. So it may be possible via web services. By developing such web services is actually a bit complex, but it can be done. I mean, the interoperability is, it can be achieved. And computing performance is like data intensive applications, mainly when you're running all these data science applications and all, and which requires high network bandwidth, and which might also result in high costs. So low bandwidth does not meet the desired computing performance, and that might actually low down the actual model. So reliability and availability is like the cloud systems need to be reliable, robust, and because there are businesses which are running on time lapse. So if there is a time lapse, it feels like the system is down, or it reduces the customer satisfaction. So it can be a threat to the actual customer who is using it. So reliability and availability is also a major threat to cloud computing. So having said this, let's have a quick demo, and we'll see about one of the products which VMware has, which is called vSphere. So vSphere is a okay. You want to share a poll, or shall we go with the demo?
No, demo. We can start with the demo.
So we are planning to show a demo of vSphere client. So this is an administrative interface. So someone asked if you want to dual boot your system, or yeah, you can use VMware clients, right? So we have a solution for that. So you can host different virtual machines which can run Windows or Linux or Ubuntu or any other flavor which you want. So yeah, we'll just show one second. Oh, mine got logged off. I forgot the password. One second.
Shall I give you?
Sorry, I got logged out of vSphere client.
Sandhya chat.
So this is our vSphere client. So this is a web UI. So this is the ESXi host, which has different data centers, and we even have storage virtualization and network virtualization also. So we'll just go through one of a VM. So for example, we'll just go through a particular VM which is having Ubuntu running on it. So the OS, which the guest OS is Ubuntu, and we also can see the hardware specs of the machine, like what is the CPU, what is the memory, and what are the network adapters installed, and other miscellaneous things. And we can even go and see the overview of how much memory is being used, what is the CPU usage, are there any spikes of disk usage, and also it even senses alerts. So so that we can just monitor and make it available always. Then we have few data stores. So you can just see where the actual location of this data store is, and how many VMs are hosted inside this, and etc. Yeah, and we can also clone an existing VM. So if you have a template and you want to clone it, and it is just a click away, and you can always clone the existing VM and go. You even can remote console to that particular VM using this vSphere client as well. So yeah, I think we are running out of time. So yeah. So
Yeah,
this
we
is
can
it.
take few questions, Sandhya, and
Yeah. So which mode of encryption does cloud computing use?
yeah, that I answered on the chat. It depends upon application to application and the service provider also. There can be multiple. So the standard ones also ES algorithm and RSA means anything. So it depends upon the application and the service provider, the which mode of application encryption they should use.
What are the security aspects provided with cloud, and how can we trust the cloud computing providers?
So
What?
again, it's the same. Yeah, again, it's the same thing. That it depends upon the cloud provider. So whom you want to trust, right? So that depends at how much secure they are. That whenever VMware deploys any application on the cloud, they also have the standards. So similar way, other cloud providers also have their standards which they follow.
Yeah. So looks like these our participants are having data issues, or trust issues on the
Yeah,
cloud.
yeah, right. So
Yeah. So,
too much worried about the security.
yeah. So cloud providers mostly take care of the security, so it's not like you have to be worried about getting the data sniffed away or something. So it's almost mostly secure. So you can trust the cloud provider.
Yeah, right. So that's all. Cloud give protection data. That's all I see, Sandhya. Means, do you see any other questions?
Yeah, no, I think mostly someone was asking if we want to use VM or a dual boot for Windows and Linux on my PC.
So it depends upon your requirement again, right? So for few applications, I have used a dual boot also. So what you want to do means that depends upon your requirement, how you want to do. So best way or more useful way is the other way where you install multiple OS and then do that.
Yes. So, are we giving the poll or shall we leave to the host?
Suryansh, yeah, you want to take the questions or shall we put the poll? Okay, let me start the poll. So we have 4 or 5 questions. So again, you have to go to the same link, poll EAB. So I'll go to the next question. Yeah, can yeah, the question is which one is type 1 hypervisor? Yeah, no responses yet. No. Type 1 hypervisor. So you should be listening to the presentation properly. So that's not the correct answer. 50% people said VMware Fusion. Whoever is not able to put that, they can put that in the chat box. Yeah, the Kumar Mrityunjay. ESXi is the right answer. VMware ESXi. So let me go to the next one now. Somehow it's very slow. Yeah. So does VMware provide all types of virtualization? That's a question. It's very slow, so maybe I'll say that you can put that in the chat box. I can read out the questions. Let me see if I can do. Yeah, now can you see the question? Yeah, that's right. VMware does provide all types of virtualization. Now let me go to the next one. Which one of the following is not a cloud deployment model? Private, public, hybrid, none of these. Very easy questions here. Please, people. No responses? Okay, so private, public, hybrid, all are cloud deployment models. So it's a none of these. So next is everyone was worried about some challenge. So what is the most important cloud computing challenge, in your opinion? You have to key in the responses here. No responses? Okay, fine. I'm taking it as a security only because most of the questions were on security.
Is it that they are not able to access the poll, or we don't see
I
any
don't know.
response?
That's what. Yeah. Please put your response in the chat box if you're not able to access that. Okay. So that's all. Suryansh,
Yes, thank you for that amazing session. Now we will have a quiz. The time limit for that quiz would be 5 minutes. Within those 5 minutes, you have to complete a Google form with several questions. Remember, the last question would be a bonus question, a subjective one, and it would count for the most points. So best of luck, everyone. I'm going to share the link in the comment section, and the form would be closed exactly after 5 minutes. So best of luck. The quiz form would close at 7:09 p.m. So fill your responses as soon as you can. Your responses in this form would decide if you're eligible for win the goodies. So best of luck. I will be closing the make sure you submit your answers if you haven't yet. I would like to repeat and I would like to request you all to submit your answers. Thank you everyone for attending this enlightening session. I would also like to thank Sandhya ma'am and Neelam ma'am for giving us some great insights into cloud and virtualization. Until next time, it's goodbye from Society for Data Science, PIT Mesra. Thank you, ma'am.
Yeah. Thank you. Thanks, everyone.
Yeah, thank you all for having us here, and you have been a very good audience, right? So have a good night. Bye.
Yeah. Bye bye.